All right, last video in this series for this lesson, multiplying a polynomial by a monomial, and this says has this really fancy looking word here, multivariate. And if some of you are good at kind of pulling words apart, if you look at that, multi means greater than one, right? More than one, and then variate just means, in our case, it means variables. So it means more than one variable. All right. So let's look at kind of like what those problems look like, and they're ugly, but they're not necessarily difficult. It's just a matter of keeping track of things. So I've got this monomial, which is pretty brutal looking, and we're going to multiply that by all three of these things. So the nice thing that you're going to experience is when you're multiplying a monomial by just one polynomial, you're usually not going to have any kind of combining or simplifying to do, because each of these, this one, and this one, they're all distinct polynomials, and you can't combine them with each other. So when you multiply them by the same thing, it's going to stay that way. So that's a nice little property you can always think of. So when we multiply these, all right, I'm gonna erase all my little marks here so I can kind of break this down for those of you who need me to do that. So I'm gonna start with my -3. I'm gonna multiply it by 2, so I get -6. Then I'm gonna start with my p variables, right? And when you multiply, you can only add exponents between the variables that are the same. So I'm going to be multiplying the p4 by the p squared, all right? And so that's going to give me p to the 6th power, because you add those exponents. And then you do the same thing with your r, all right? So you got r cubed and r to the 4th, so you're going to get r to the 7th power. And that's pretty much the same process you're going to do every time, all right? And the next one, -3 times -6, is going to give me positive 18. We're going to do our r's. So I got p to the 4th times p to the 6th, which is going to give me p to the 10th. And then for my final, we have r third and r third, which gives me r to the 6th. And then that last little bit is just basically the only thing we have to multiply is just our coefficients. So you got -5 times -3, which gives me positive 15, and then you're going to tack the rest of this stuff on to that. So I will do that and keep with the color combination. P to the 4th, and then r cubed. All right. Oh, I did the wrong color there. I'm failing at this thing here. All right, so you can see in each of these cases that I've got 3 different terms, right? I've got this term, I've got this term, and I've got this term. And I can't combine any of these, because in order to combine it, my p would need to be the same on all 3 of these, which it's not, and my r would need to be the same in all 3 of these, which it's certainly not. So I would need those 2 criteria to match up in order to do that. And so this is just an example of where you're multiplying that monomial, and then you're going to wind up with another 3-term polynomial that that is already simplified as much as it can be. Even though it looks ugly, this is simplified. All right, let's take a look at this next one. And I'm going to do this all in one color, and so that you have to kind of look at this and think about this. So I'm going to take this 15t, and I'm going to start by multiplying it by this. But I am going to switch colors and do this in white. So 15 times 10, all right, so you're going to have to listen. 15 times 10 is 150. And then I can multiply this t times this t to the 5th here. And so that's going to give me t to the 6th. And I don't know why I copied this down from the book. I don't know why they have the y's in front of the t's. Normally you put the variables in order, but I'll just keep it the way they have it. So we'll go y to the 3rd, because there's nothing for the y to the 3rd to multiply by. And then t to the 6th power, all right? Because you have 1, and then you have 5. All right, now let's do t to the 6th. So our next term, so plus 15 times 5 is 75. And then we have y squared again, because there's no y term here. Then you have t squared. And now I'm completely dealing with just this part right here. So I'm going to have minus 2, because 2 times 1 is 2, y squared, and then just a t, and then minus 8y to the cubed. And so if I look at this, I have to be careful with this, and I have to make sure there's nothing I can combine, because I had two separate products going on, right? I had this product over here, and then I had this product over here. So that's two separate products, and you want to make sure there's nothing that can be simplified between the two. And if I look at this, I got a y cubed, y squared, y squared, y cubed. Well, I can't, if I look at this critically and say, well, I've got a y cubed term here and a y cubed term here, I can't combine those because this one contains a t6 and this one doesn't. So those are fine just how they are. And you're going to kind of encounter the same thing if you're looking at your y squared terms. Well, I've got a y squared here and I've got a y squared here. But the exponent on this t is 2, and the exponent on this t term is 1. So I can't combine those. So you got to be really picky and really look at this stuff and make sure you're not doing things you can't do. So your finished answer is just going to be 150 y cubed t6. I'll just rewrite it again so you see it. Y squared t squared minus 2y squared t minus 8y cubed. And so this should give you kind of an idea about how these multivariate expressions, when you're having products, in other words multiplying with them, kind of look, and what you got to look for. And you will have some where you can combine terms. Neither of these shows that, but that's sort of the basic idea of what we're looking at. So good luck.